Hi, my name's Dr. Bob Charley. I'm the Forage Products Manager with Lallemand Animal Nutrition, and I was invited here for the Nebraska Beef Conference to talk about the corn silage fermentation process. Now, the most important thing to understand when trying to make high quality corn silage is that the most major determinant of the quality of the material that you're going to produce is the quality of the material that comes in from the field. So you really need to get that stage of harvest right to optimize the quality of the material that you get. That being said, my talk was about the corn silage fermentation process, and that process is an anaerobic process. Fermentation by definition is anaerobic. So it doesn't start until we've got the silage into the pit, we've got it covered in sealed, and all of the oxygen has been displaced or consumed from the body of the silage. So the quicker that we can do that, we can achieve that, the better it is, because the faster we get the fermentation started. So the kind of factors that impact that are obviously the speed at which you bring the material in from the field, the chopping length, the moisture content, the amount of packing effort that's put into packing the silage, and then of course the speed at which you cover it and seal it. And it should be covered and sealed effectively, efficiently, in order to maximize the speed of it at which we get that anaerobic conditions. So now we've got the anaerobic conditions, the ensiling process can begin. And what we want to dominate the start of that ensiling process is homolactic lactic acid bacteria, because under anaerobic conditions all they produce is lactic acid from 6-carbon sugars. So it's a very efficient process, and lactic acid is the strongest of the fermentation acids, so we're going to bring the pH down quickly to below the critical control point of pH 5, which is where we knock out things like Clostridia, E. coli, Listeria, and also the enzymes that the plant is secreting to try and break the plant down and return it to the soil. We shut all those things down as we get below pH 5. So we want to get down below that as quickly as possible, and as I say, producing lots and lots of lactic acid is the key to that, so having a homolactic domination to the fermentation. Okay, so we've produced all our lactic acid, we've got the pH down below 5 quickly, we've reached somewhere around 4, let's say, and now we go into storage, and then we get to feed out. And feed out is where our next potential problem occurs, because during feed out we re-expose the silage to oxygen, and if we've got high levels of yeasts in the silage, those can then grow and use up dry matter, burn energy and things like that, so that we lose the valuable nutrients that we've preserved during the ensiling fermentation. And the losses at this end can be significantly higher than the fermentation losses. We can get 25, 40, 50% dry matter losses during this feed out stage compared to maybe 10, 15% losses in the fermentation stage. So we need to control that. We need to keep the silage as stable as possible, treat it with an inoculant to give that stability, and manage the feed out rate so that we don't get heating and spoilage.